it's been a while since I've recorded any video on this, but we've made some good progress with the board. If you remember last time, I was just inserting these rare earth magnets, which on the other side of the board, this instruction board, will hold in our instruction blocks, which will complete the circuits here. We've put in copper tape to create two sets of rails, if you like. There's a ground rail here which goes around and is connected via this black cable to the ground on the Arduino board. There's a plus 5 volts rail going around, which is connected by this red cable going into the plus 5 volt header pin here on the Arduino. And then we've connected these pairs of contacts, which on the other side will make contact with the bottom of the instruction blocks. We've connected one of the contacts to the plus 5 volt rail via a resistor in each place. And then on the other side we've connected the other contact to the ground rail via a piece of copper tape. I've inserted a whole series of LEDs into the holes which were cut in the laser template, and these LEDs are connected via a resistor to the again to the, in this case, to the ground rail, and that's so that when we supply 5 volts from the Arduino board with I think up to 40 milliamp current, we don't fry each of these LEDs. So the resistor acts to drop the current that they'll draw. So we've got a basic circuit. We've got plus 5 volts flowing around, going back to the board via this ground rail here. We have a push button over on this side. It's under this jungle of wires here, which you can see again is connected to the plus 5 volt rail, and the other side of the switch, it's a push button switch, is connected via a resistor to the ground rail. And this point here we've got this black cable goes across to one of the digital pins on the Arduino board. So that will be looking, in the software, they'll be looking to read a high or low value. So, and it's digital, so it's just high or low. So that's the reason for having this resistor in place, so that and the pin connected indirectly, if you like, to the circuit. So when the push button is pressed, we've got plus 5 volts flowing from one side of the switch to the other, and the digital pin read will be high. And when it's not pressed, we have no current flowing, and there's a voltage difference here. This is plus 5 and this will be 0. So this will, or approximately 0, this will read low on the digital read. So this is the push button that allows us to detect a button press, which then reads all of the different resistance values of the instruction blocks that are plugged into each of these sets of contacts. And the LEDs give us an indication, a visual indication of when there's an instruction block plugged in and forming part of the circuit. Each of those instruction blocks, or from the contacts here, so exactly at the same point where the resistor is connected from one side of the instruction block connections to the plus 5 volt rail, we also take a cable, a wire, into one of the analog read, one of the analog pins. So we'll use analog read to get a value for each of those, and those values effectively will read the resistance, the total resistance across these two contacts, and that resistance is determined by the resistor that we've built into each of the instruction blocks. So that's it. Looking at the board itself, we've got an Arduino Mega, and really that's just about giving us some extra pins. We've made some headers here using male and female header pins, and so that just allows us to easily plug these wires into these headers on the board itself, on the Arduino board itself. And this board here is a wireless prototyping shield from Arduino, and this is really just being used to provide us a convenient way to connect this XBee wireless controller communication board. And this is what will communicate between this instruction board setup and the Cubetto itself. So in the Cubetto there's another Arduino board, a Uno in this case, with a Proto Shield, wireless Proto Shield plugged into that, and an XBee wireless communication board plugged into it. So these two XBee boards will communicate with each other. But beyond that, it's it's a simple case of reading a bunch of values, analog values, based on the resistance from each of the instruction blocks, and those go into analog pins and use analog read in the Arduino code to get those values and determine what instruction will be given. So one resistance value says go forward, another says go left, another says go right, and another one says perform the function in the function block area. And then these digital pins are being used for the LEDs. So that's it really. We'll go to the next step now, which is to encase this in the rest of the instruction board plywood housing, and we'll work on the Cubetto itself.